How small is small? Like, really small. Smaller than a grain of sand? Smaller than a speck of dust? Smaller than your chances of getting a text back from your crush? Today, we're zooming in, way in, to explore nanotechnology, atoms, and just how tiny the building blocks of our universe actually are. Let's start with some perspective. A human hair is about 80,000 to 100,000 nanometers wide. A red blood cell? Around 7,000 nanometers. An atom? Roughly 0.1 nanometers. That means you could line up about 10 million atoms across a single strand of hair. 10 million. To an atom, your entire body is basically a continent. To nanotechnology, a cell is a galaxy. We are, quite literally, giants walking around in a universe made of Legos so small we can't even see them. But what is nanotechnology? In simple terms, nanotechnology is the science of building and manipulating things at the scale of nanometers, 1/1,000,000th of a meter. It's where physics, chemistry, biology, and engineering all shake hands and say, let's make something really tiny and really cool. At the nanoscale, things don't behave the way you expect. Friction changes. Electricity behaves differently. Materials become stronger or weaker or transparent or sticky or all of the above. Basically, physics at the nanoscale says, the rules? Yeah, we've decided to remix them. Take gold, for example. On the macro scale, it's shiny and yellow. But make gold nanoparticles? They can appear red, purple, or blue, because light interacts differently with particles that small. Or carbon. On the normal scale, it's graphite in your pencil. But rearranged at the nanoscale, it becomes graphene, a single layer of carbon atoms that's stronger than steel, thinner than paper, and conducts electricity better than copper. You could make flexible screens, supercapacitors, or armor that weighs less than a t-shirt and could stop a bullet. It's not science fiction, it's just really, really tiny science. But it's not just about making materials cooler. Nanotechnology could revolutionize medicine. Imagine a future where tiny machines, smaller than a cell, swim through your bloodstream. They could deliver medicine directly to a tumor. Or clear out plaque from your arteries. Or, let's be honest, just patrol your body looking cool while doing it. We call these nanobots. Are they real yet? Sorta. We're building the components, motors, sensors, drug delivery systems. The idea is to build systems that can operate at the cellular or even molecular level. Still early days, but promising. Then there's data storage. You know how we keep making phones thinner and faster? That's because engineers have been shrinking transistors on computer chips for decades. We're now working at the 3 to 5 nanometer scale. That's only a few atoms across. Eventually, we'll hit a wall, because you can't build a switch smaller than an atom. Or can you? Some scientists are trying to store data using individual atoms. Like actually encoding bits of information by positioning atoms on a surface. That's like writing an entire book using grains of sand. It's not very fast, and it's incredibly complex. But if it works, we could store the entire internet on something the size of a sugar cube. And don't even get me started on quantum dots, nanorobotics, targeted cancer therapies, smart textiles, self-healing materials. Basically, if it sounds futuristic and it's very small, nanotech is probably involved. But here's the catch. Working at the nanoscale is hard. Atoms don't line up because we politely ask them to. They bounce, repel, get sticky, and generally act like toddlers hyped on sugar. We need clean rooms, scanning electron microscopes, atomic force tools, just to see what we're doing, let alone control it. It's like trying to build a ship in a bottle, using robotic tweezers, blindfolded, while the bottle is vibrating. Still, we're making progress. So how small is small? If you took 1 second to count every atom in a single grain of sand, you would never finish. In fact, the number of atoms in 1 grain of sand is greater than the number of stars in the galaxy. And yet, we're learning to manipulate them. We're learning to build with them, design with them, heal with them, power with them. We're turning atoms into tools. So the next time you hear the word Nanotechnology, don't think of something small. Think of something huge. Because when it comes to shaping the future, the smallest things might matter the most. Thanks for watching. If you enjoyed this microscopic adventure, give it a like, drop a comment. What's the coolest tiny invention you've heard of? And don't forget to subscribe, because science only gets weirder from here.